Howdy, 8th grade. Today we're going to be talking about something that I hope is going to be fairly conceptual, so we can just kind of work it out in our heads and kind of use some stuff we already know to just build this. So I'm going to try to walk us through those steps of how that works. But what we're looking for today is I'm going to give you guys 2 points. I'm going to ask you guys to figure out what the distance is between those points. So what that's going to look like is I would give you the points 1, 5, and let's do 4, 9. And I would ask you to tell me how long that is. So let me draw that real quick. All right, so here is my plane with the 2 points in it. 1, 5 is right over here, and we're going to label that point A, and so we're going to label B just so we know what I'm talking about. That's A, and that's B. So if I want to try to figure out the distance from this, we have to look at what we know so we can figure out how far it is from A here to B there. So I know that A starts at 1 and B's x value is 4. So to get from 1 to 4, I'd have to go over 1, 2, 3 times there. And A's y value is 5 and B's y value is 9. So to get from 5 to 9, I'd have to go up 1, 2, 3, 4 spaces right there. So I'd have to go over 3 and up 4, and I know that. My x-axis and my y-axis are going to be perpendicular, so I know that. So this right here is 3, that's 4, and I'm not sure what this length is. And I'm really hoping some of y'all are screaming at me right now. That's the Pythagorean theorem. We should be using the Pythagorean theorem, so that's exactly what we're going to be doing. I'm hoping some of y'all were shouting that at the screen. If not, shout it right now, especially if you're listening to this in Mr. Costello's class. I think that'd be a lot of fun. Pythagorean theorem, that's what we're doing. So, we're going to look here and plug in the Pythagorean theorem to figure out what that last length of my triangle is. So know that 3 squared plus 4 squared is going to equal my length. I'm just going to call that L squared. It would be 9 plus 16 equals L squared. 25 equals L squared. And what squared is 25? Well, 5 squared is 25, so 5 equals L. So that tells me that my length from A to B is going to be 5. That distance there is a distance of 5 units, and we've made it from A to B. And that's pretty much how we're going to do everything we need with distance, is we're going to keep using the Pythagorean theorem. So eventually we can get to the point, let's try one without actually graphing it, or we can do this purely using the points that they gave us. So we're going to do another example real quick. And I'm going to have 3, negative 2, and 6, 4. So what this is going to look like is I need to figure out what my x distance is. And to do that, I'm going to do x2 minus x1, which is 3. I need to figure out what my y distance is, which would be, sorry, let me explain that 3. x2 would be 6, x1 would be 3. 6 minus 3 is 3. Don't want to skip those steps. So the y distance would be y2 minus y1, which would be 4 minus negative 2. So that's 4 minus negative 2, which is going to give me 6. So my y distance is 6, my x distance is 3. Now that I know that, I can draw this. My x distance is 3, my y distance is 6. Pythagorean's theorem comes in handy once again. I get 3 squared plus 6 squared equals my length squared. And 3 squared is 9. 6 squared is 36 equals my length squared. 9 36 is 45. So my length squared, square root of 45 equals my length. We can do a bit of simplification here. This goes to 9 and 5, just 3 and 3. So I would end up having 3 roots of 5 equals my length. And I kind of rushed through that last part because I'm hoping we're doing pretty well on radical simplification. So once we get to this point right here, I'm hoping this kind of comes pretty quickly. That's something we've been covering for a little bit now. So that's pretty much just how that works, is we would use Pythagorean's theorem to figure out our midpoint. Sorry, not midpoint, our distance. What we're covering next is midpoint. Here we go. Let's talk about that. Midpoint. And we're actually going to go back to our very first example, so I'm going to draw that again. Alright, so here's what we started with, my 2 points 1, 5 and 4, 9 back on this graph, and I want to find the midpoint. So I know midpoint's not a word we've used much, but it means exactly what it sounds like. It's the point that's in the middle. The midpoint is the point in the middle. So if we want to find the point that's in the middle of these two, we're actually going to just kind of cheat a little bit, and we're going to make a new point here. And we're going to start by saying, well, what's in the middle of 1 and 4? So we're going to take an average, and that's going to be 1 plus 4 divided by 2. And then we're going to ask what's in the middle of 5 and 9. And we're going to do the same thing here. Take an average, 5 plus 9 divided by 2. And if we do this, we end up with 5 halves and 7 as our point. So let's put this on here. 5 halves is 2.5 right here, and 7 is, let's see, 5, 6, 7. So my midpoint would be right there. And looking at it, that looks pretty much right in the middle of my two other points. So that's what a midpoint means. It means right in the middle, and the way we find that is we just average our x's, we average our y's, and that gives us our new x value and our new y value. So just from that, the midpoint's pretty simple. We find the middle of our x's, middle of our y's, stick them together. We got us a midpoint. We are good to go. And that's pretty much what we have learned today, is how to find midpoint, which is with averages, and how to find distance, which is with the Pythagorean theorem. I hope y'all have a delightful day, and I will see y'all in class tomorrow.